Greetings of the day. This is Dr. Khalid. Before starting our discussion on antibiotic resistance, I request you to subscribe to this channel and click on the bell icon to make sure you get the latest health and wellness updates backed by strong scientific evidence. I hereby assure you of the authenticity of the scientific facts presented through this YouTube channel and remain committed to making your lives better every single day by increasing your health awareness and knowledge of a variety of disease conditions. I firmly believe in the notion that disease prevention is always better than cure. That is why I'm urging your kind support to expand our health awareness mission and minimize the dependence of people on avoidable costly prescriptions and avoidable medical procedures. Antibiotic resistance occurs when bacteria smartly change their structure to escape the attack from antibiotics. Interestingly, some bacteria even change the antibiotic configuration to reduce its bacteria-killing potential. Some of them have the ability to push the antibiotic out of their cell, and some even change their surface and binding sites so that the antibiotic cannot get in. These escape mechanisms and tactics of bacteria help them survive despite their exposure to a powerful antibiotic. A variety of bacteria consistently learn new ways to avoid antibiotic invasion and pass on their learnings to their new generations. Some of the smartest bacteria change their DNA configuration to counter the adversities of the strongest antibiotics and render them ineffective. Bacteria can develop antibiotic resistance by four strong strategies. Number one is the intrinsic resistance. Some bacteria can change their shape or parts over time to avoid being killed by an antibiotic. For instance, penicillin works by attacking the cell wall of bacteria, but some bacteria do not have a cell wall at all, and they are not affected by it. Number two is the acquired resistance. Some bacteria can learn to resist an antibiotic that used to kill them before. They can do this by changing their DNA in a way that helps them survive or by getting DNA from another bacterium that already knows how to resist. An example is Mycobacterium tuberculosis that can resist rifamycin. Number three is the genetic change. The DNA of a bacterium can change and affect how it makes proteins, leading to different parts and different binding sites that the antibiotic cannot recognize. Bacteria that live together can also have genes that make them naturally resistant and change their DNA. As an example, E. coli and Haemophilus influenza, which can resist trimethoprim. Number four is the DNA transfer. Bacteria can exchange genes with other bacteria and pass on the resistant DNA through a mechanism known as the horizontal gene transfer. This usually occurs by transformation, transduction, or conjugation. Transformation is when bacteria take in loose DNA from other bacteria. Transduction is when bacteria are eaten by the viruses, and conjugation is when the bacterium comes in contact with another bacterium. An example is a Staphylococcus aureus, which has the power to resist methicillin. A lot of bacteria can fight off more than one antibiotic. For example, some E. coli and Enterococcus are blocked by ciprofloxacin, ciprofloxacin, or erythromycin are usually resistant to at least one antibiotic and sometimes many kinds of antibiotics, including macrolides, tetracyclines, beta-lactams, quinolones, sulfonamides, and even rifamycin. Sometimes we use too many antibiotics or use them even when we do not require them. A long time ago, Sir Alexander Fleming warned us about the problem. He was one who discovered the first antibiotic called as penicillin and raised the possibility that people will want more and more antibiotics and misuse them in the near future. Many studies now have shown that more antibiotics or excessive use of antibiotics lead to the development of resistant germs, which can again share their genes to other germs, which can further learn to resist more antibiotics. They can also change their genes by themselves and become resistant. Antibiotics kills the weak germ, but what happens? They leave the strong ones behind, which can easily multiply and spread to various parts of the human body. There have been reports indicating that too many doctors around the world give too many antibiotics or the wrong one to their patients, unfortunately. Across the globe and in the United States in particular, people use a lot of antibiotics. And one study found in 2010 that each person in the United States uses 22 doses of antibiotics on an average. Some states use even more antibiotics than others, while in some other states, people get more than one course of antibiotic each year. Sometimes what happens, doctors give antibiotics that are not right for the infection. They even prescribe them for too long or too short durations. Some studies show that this happens a lot of times in hospitals and in the ICUs in particular. Say, for an example, one study found that 30 to 50% of the antibiotics given in the hospital were wrongly administered. They were even not required at all. Another study found that 7.6% of patients with pneumonia in the United States got the right antibiotic compared to 89% in Sweden. Giving antibiotics the wrong way does not improve healing, and they can rather cause potential side effects. Low doses of antibiotics can make bacteria change their genes and become more dangerous and more likely to spread to other people and animals. For example, low doses of some antibiotics can make bacteria like Pseudomonas aeruginosa and Bacteroides fragilis change their proteins and become more dangerous to humans. One way that antibiotic resistance develops is when people take antibiotics themselves without a doctor's prescription. This is called as self-medication, which is more common in poor countries where people and health workers do not know much about antibiotics usage. A systematic review of 34 potential studies from underdeveloped countries with 31,340 people found that 39% of them used self-medication, and some of the mistakes they made were taking antibiotics for either a very short or a very long duration, or taking too many dosages, or even recommending antibiotics to other people without any medical prescription. Another way that antibiotic resistance develops is when people travel to other nations with poor hygiene. Every year, 300 million people visit countries with poor hygiene, and out of them, 60 to 150 million come back with diarrhea. Some of these individuals take antibiotics by themselves, but this does not stop them from carrying the germs in their bodies, and they can swiftly pass these germs to their surroundings. Superbugs are bacteria that are resistant to multiple or all antibiotics. Some superbugs, such as MRSA or methicillin-resistant Staphylococcus aureus, CRE, carbapenem-resistant Enterobacteriaceae, or C. difficile, Clostridium difficile are becoming increasingly common. Superbugs can cause infections. They are often serious and difficult or impossible to treat. Some of the worst superbugs are found in hospitals where they can infect patients and staff. These superbugs have special ways to avoid being killed by antibiotics and making them useless. Superbugs can change their genes or get genes from other germs to learn how to resist antibiotics. They can also get genes from the environment where there is a lot of DNA scattered from dead things. They can eat this DNA and use it to protect themselves from a variety of antibiotics. The dangerous superbugs are becoming resistant to all kinds of antibiotics, whether they come from nature or from labs. For example, vancomycin is an antibiotic that stops some bacteria from making their cell walls. But some bacteria have plasmids that make them resistant to vancomycin. Plasmids are small pieces of DNA that bacteria can share with each other. The example is daptomycin, which is an antibiotic that attacks the cell membrane of bacteria. The cell membrane is like a skin that covers the cell. Daptomycin makes holes in the cell membrane and lets things leak out. This makes the cells lose their power and stop working. But some bacteria are capable to resist daptomycin by challenging their cell membrane. Antibiotic resistance in bacteria is a big problem that makes it hard to treat infections. The Centers for Disease Control and Prevention says that more than 2 million people in the United States get sick from antibiotic-resistant bacteria every year, and at least 23,000 of them die. Antibiotic resistance makes it harder for our immune system to fight germs that can cause more problems to people who need other potential treatments like chemotherapy, dialysis, surgery, or joint replacements. It can also affect people who have chronic disease conditions like diabetes, asthma, or rheumatoid arthritis. Because of the antibiotic resistance, doctors must use a stronger and more expensive antibiotics that are not always available in poor countries and have more side effects. This eventually increases the overall healthcare cost. Antibiotic resistance can cause many problems for us in the world, such as more people can die from infections that are hard to treat with antibiotics. People who get sick from antibiotic-resistant germs may need to stay in the hospital longer and get more tests and treatments and experience a high risk of mortality. This can make healthcare more expensive for everyone because hospitals and doctors have to use more resources and charge more money. Antibiotic-resistant germs can also spread more easily to people and animals because they are harder to stop with antibiotics. This can damage environment as soon as these germs enter the soil, water, air, and affect other living beings. Antibiotic resistance can also minimize food security since the resistant germs can infect crops and animals that we eat and reduce their health and reproductive capacity. Antibiotic resistance can also cause economic losses due to its potential impact on agriculture, tourism, trade, and manufacturing. Use antibiotics only when a qualified doctor tells you to do so. You must follow the prescribed dosage and timings since they are customized based on your health requirements. You should continue taking all prescribed antibiotics on time, even if you feel better before finishing them. This makes sure that all the targeted terms are hit well and they lose the scope of developing antibiotic resistance. Do not take antibiotics by your own and also never recommend them to others. Make sure to maintain hygiene and keep your surroundings clean and safe from germs. This can be done by washing your hands, covering your coughs, cleaning your wounds, and properly disposing the waste materials. You should get vaccinated against some of the diseases that can be prevented by vaccines. You just need to follow the vaccination schedule prescribed by your doctor. You should raise awareness and advocacy about antibiotic resistance and its mitigating approaches. This can help you educate people about the causes, effects, and solutions of antibiotic resistance. This can be achieved by consistent learning, sharing information, and joining health awareness campaigns or speaking up for the change. Talk to your doctor about antibiotic resistance. Keep learning about antibiotic resistance and its prevention approaches. Share this information with your family and friends. Get involved with your community to raise awareness about antibiotic resistance. Support organizations that are working to combat the massive impact of antibiotic resistance on human lives. Let us join hands against the improper use of antibiotics, and together we can surely make a difference. Thanks for watching.